Hello everyone, how are you? Hope you're all doing great. I have a great news for you dear students. From this video onwards, I'll be starting the Karnataka CET previous year questions and the solutions. Okay. Now, I have selected last 11 years of questions chapter wise. This is most important point. Okay, so I'll be doing it in chapter wise, so I'm damn sure that this will help you to upgrade your preparation level. Okay, you have 2 months for the Karnataka CET now, so definitely you can prepare well so that you can increase your ranking as well. Okay, so now let me start from the first chapter of your first PU, that is some basic concepts of chemistry. So I'll be going in a descending order, dear students. That is, firstly I'll be taking up the 2020 question, last year question, then it will be 1918, and in that way it will proceed. Okay, so definitely we will be knowing what are the concepts which chapter wise, okay, on which we have to focus more, so that definitely we can excel in the result. Fine. So the first problem which was asked in 2020, 0.4 gram of hydrogen is made to react with 7.1 gram of chlorine to form HCl. The volume of HCl formed at 273 Kelvin and 1 bar pressure is. So as soon as you look into the problem, the two reactants are given with the specific amount, right, and product is asked, and that to volume. So two things you have to conclude from this is it is a stoichiometry calculation where mass can be related, or mass has to be related here to the volume. Okay, so mass volume stoichiometry calculation problem. Then since specific amount of the reactants are mentioned, so limiting reactant problem. This much you have to understand from the these types of questions. Fine, no? So let us write the equation first, the solution for this. Okay, so H2 combining with Cl2 to give 2HCl. This is a balanced chemical equation for this. Now according to the stoichiometry of the reaction, write the amounts. So 2 gram of hydrogen, because it's molar mass, right, combining with 71 gram of chlorine to produce 2 times the HCl volume. So 1 mole of HCl in gaseous state, you know, occupy molar volume, that is 22.7 liters, since pressure is in bar. Okay, otherwise if it is in atmosphere, then you have to consider 22.4 liter. So now I'll write this as 2 into 22.7 liters. Fine, no? So let us write the given data. What is that? 0.4 gram of hydrogen is combining with, or made to combine with, 7.1 gram. Now will you identify the limiting reactant? Yes, easy. Why? Because 2 gram requires 71 gram. So 0.2 grams divided by 10 requires 7.1 gram. But I'm having 0.4 gram excess, isn't it? So H2 will become excess reagent. Cl2 is a limiting reactant. Let me write LR. Okay, limiting reactant. Now the point, the ultimate or the very important point under limiting reactant concept is that the product formed is depending on the limiting reactant, because once it gets consumed, no product can be possible. So as a result, what I can do here is I'll connect the product formed based on the limiting reactant. So cross multiply. What is the product formed? 71 gram gives 2 into 22.7 liter. 7.1 gram will give how much? So you cross multiply that. That is nothing but 7.1 into 2 into 22.7 liter divided by how much it is? 7 point, am I right? No, 71. Fine. So ones are 10 times, isn't it? So 2 into 22.7 is 45.4 by 10 is 4.54. Done. 4.54 grams of HCl. Sorry, it is in liter, isn't it? Because volume. So 4.54 liters of HCl is going to produce. So your answer is option A. Okay, so that is about the first one, and important, it is asked in 2020. And if you go for the last before that year, that is 2019, and you will definitely get surprised, because same concept is asked, okay, in that year as well. So what is that? The mass of AgCl precipitated when a solution containing 11.7 gram of NaCl. So reaction between NaCl and AgNO3 to give silver chloride, right? So again specific amounts are mentioned, so it is damn sure again it is a yes, limiting reactant problem. Fine, shall we go for that then in the same way? So let me write here the solution for the second one, that is 2019 question from the basic concepts of chemistry chapter. So how to do that? Write a reaction first. AgNO3 combining with NaCl, right? What is going to be produced? AgCl, right? Plus NaNO3. Write the reaction. Fine. Now specify the amounts according to the balanced chemical equation. How much of AgNO3 required for 1 mole of NaCl? Its molar mass: silver 108, nitrogen 14, oxygen 16 into 3, 48. So totally it is 170 gram. Consume how much? 58.5 gram of sodium chloride. If it is so, then what is the AgCl produced? 108 plus 35.5, so it is 143.5 grams. Did you get that? Yes. Now write down the given amounts. It is 3.4 gram of AgNO3, so let me write it, 3.4 gram, and that of sodium chloride is 11.7. Are you getting? What is the AgCl produced? The question again, find out the limiting reactant first. So what is the limiting reactant? You observe, okay, it is not required to cross multiply again, okay, I mean to see which is the limiting reactant. Just looking into the data I will come to know how 58 gram of NaCl require 170, so more than triple of, or at least almost triple of that of sodium chloride, right? But here we are having excess of sodium chloride. AgNO3 is in lesser amount, isn't it? To be precise, it required, greater extent, but it is in lesser amount, so definitely limiting reactant is silver nitrate. Now product form depends on silver nitrate. So how to compute it? So just observe here, I'll be taking 170 gram and 143.5 gram, then 3.4 gram gives how much? So it is 170 giving 143.5, right? So 3.4 how much? So multiply it, 3.4 into 143.5 divided by 170, and that will be your answer. So how to do this? Let me write it, 3.4 into 143.5 divided by, so let me come here, okay, hope you can see this now, 170, right? So 170 ones, 17 ones, 10 times it will become, right? It is 2 times 34, so point, right, 0 2 times. Do you agree? Yes. Now 143 double is, this will become 1, see, I'll write 2 into 10 to the minus 2, so this is 1.43 into 2 is 2.87 grams. So is there any option? Yes. So option B is the right answer for your second question. Isn't it easy? And again, more surprise for you, even in 2018 the question is based on the same concept. So in this way, definitely, right, if you study chapter wise, then you are having certain concepts in every chapter which are asked more number of times, so you can focus more on that, so you will never miss such type of concepts even if it is asked in this year's CET. Okay, so that is the advantage of studying previous 10 years question paper. So this is the best analysis, dear students. Okay, now look into this problem. 1.0 gram of magnesium is burnt in 0.28 gram of oxygen, so which is a excess reactant, and how much it is to be calculated. Unlike the previous two cases where limiting reactant need to be found out, here it is excess. Of course, one you find out, the other can be automatically identified. So we'll write that reaction. Magnesium, okay, combining with oxygen, as you know, produces magnesium oxide, right? Balance the equation. So I require 2 magnesium and the formed will be 2 magnesium oxide. Now write down the data according to the given balanced equation. So 2 into magnesium, magnesium mass is, atomic mass is 24, so totally it is 48 gram. or let me write 2 into 24. So it is easy to identify. Okay, so 2 into 24 gram consumes 32 gram. It is not related to product, so we won't be writing it. Okay, it's not required. Now in equation it is told 1 gram of magnesium and 0.28 gram of, right, oxygen is being taken. Now identify the limiting reactant or excess reactant, anything. Now you observe here 48 gram consume 32 gram. So what is the ratio between magnesium and oxygen? 48 and 32 divided by 16, isn't it? 3:2, that is 1:1.5. So for every 1 gram of oxygen you require 1.5 gram of magnesium. So 0.28 gram requires how much then? Magnesium, how much? Isn't it? Are you getting how to solve that? So you write 48 gram requires 32, 0.28 gram requires how much? Or without doing such calculation you can find out how it is. 1:1.5 ratio, the masses. So 1 is here 0.28, it's 1.5 times how much? 0.5 times is half of it, 0.14. So 0.28 plus 0.14 is 0.42. So 0.42 gram you require, but you have 1 gram. So excess reactant is magnesium. Done. So how much of it? So you had initially 1 gram minus you require 1.5 times the order of 0.25. So it is 0.42. So remaining is 0.58 gram of magnesium in excess. So magnesium, and it is 0.58 gram. So all the 3 years 18, 19 and 20 it is based on limiting reactant concept. So what conclusion you can draw from this? You have to concentrate more on limiting reactant because these are recent or past 3 years. Done. So let us move on to the next one. Okay, fourth problem, we'll see which concept is that. Okay, then so move on to the fourth question, so which is 2017. Okay, the year. So if 3 into 10 to the power 20 molecules are removed from 98 milligram of sulfuric acid, number of moles of sulfuric acid left are. So definitely it's a mole concept question, right? So how to solve this? So to find out how many moles of sulfuric acid are left, so first we should find out how many moles of sulfuric acid were there, then how many moles are removed. Right? So connect these grams and molecules into moles, then obviously it is possible to calculate. So let us do that in one step. How to do it? So let me give a formula here. Okay, number of moles of sulfuric acid left, which is also I'll write as NL, which is equal to total number of moles which you had and the number of moles removed. So very simple it is, right? So immediately you can substitute total number of moles. How many? 98 milligram was there, so 98 into 10 to the power minus 3 milli, am I right? Yes, divided by, see, mass by molar mass is the formula to calculate mole, so divide by 98 gram, which is sulfuric acid molar mass, minus number of moles removed, how many? 3 into 10 to the power 20. So whenever a number is given, you supposed to divide that by Avogadro number to get the moles. So you have three formulae to be precise to calculate moles, which are those: mass by molar mass, which is equal to moles, number by Avogadro number, again moles. If it is in volume, then volume by molar volume, 22.4 or 22.7 depending on the unit of pressure. So now I have a formula here for this. Right, removed, how many moles are removed? 3 into 10 to the power 3.01, right? 20 divided by Avogadro number 6.02 into 10 to the power 23. Now 98 get cancelled, so it is 1 into 10 to the power minus 3 minus 3 ones are 3 twos are 0.5. 1 by 2 is 0.5 into 10 to the power minus 3. Are you getting this, students? So it is 10 to the power minus 3 minus 0.5 into 10 to the power minus 3. So remaining is 0.5 into 10 to the power minus 3. So which is that option? Exactly, option D is your choice. Next, moving on to the next, that is 2016. Please do observe, dear students, here is a mole concept, and again you are asked with mole concept. So 2-3 years if you see 20, 19 and 18, these 3 years you had, right, on the concept of Absolutely right. Remitting reactant. Now next 2 years they have asked on the concept of, absolutely it is moles, and you see here it will continue like that. Okay, so we'll come to that later. Now we solve this problem. How to solve this? The number of oxygen atoms in 4.4 gram. Now whenever mass, volume or molecules are given, to find out the atoms or molecules, you have to make use of the concept called mole. So it is again mole concept. You find out 4.4 gram of carbon dioxide is equal to how many moles? What is the need for that calculation? Because we supposed to know that 1 mole of any substance occupy or contain Avogadro number of molecules or occupy molar volume. So if it is a gas, now here it is told mass and the atoms of oxygen are asked, so it is nowhere related to the volume calculation. So what do you do? Find out how many moles of carbon dioxide were there, and if you know that many moles into Avogadro number will become the molecules, but it is question is oxygen atom. So how to connect that? 1 molecule of carbon dioxide contains 2 atoms of oxygen. So in that way you can go for. So in single step how to complete it? So this is the easiest one. How to do that? Number of oxygen atoms. Okay, number of, we'll go for the direct calculation. Number of oxygen atoms, okay, is equal to how many moles are there? 4.4 gram divided by carbon dioxide molar mass is 44, right, into each molecule or each mole contains 2 moles of oxygen atoms, because we are calculating now oxygen atoms. So into 2. Why we need to multiply by 2? Because oxygen atom present in 1 molecule of CO2 is 2. So therefore moles into the atoms of oxygen. What next? Each mole contains Avogadro number, so multiply by that. 6.02 into 10 to the power 23. That will be done now related to this problem. So 4.1 is the 10 times the, right? So 2 into 6 is 12, by 10 is 1.2. So 1.2 into 10 to the power of 23 atoms of oxygen will be there. Okay, atoms. So which is that option, dear students? Go for option A. Done? Easy? Yes. Next, it is a concept of called empirical formula and molecule formula calculation. So here the question is, what is the empirical formula of the given composition of organic compound? Now carbon is given, hydrogen and nitrogen. So your organic compound contains carbon, hydrogen, nitrogen. So how to compute? To be precise, it is a 3-mark question in first PU board exam. Okay, so now it is to be done in single step. How? Just observe. Okay, so you write the ratio of the atoms given: carbon, hydrogen, nitrogen. Now I'll write that. Okay, carbon, hydrogen, nitrogen molar ratio to be found out. So for that, what you're supposed to do? Divide the atomic mass or divide the percentage by atomic mass. That will give you the mole ratio. So what I'll do is I'll go for that carbon, which is 40 and its atomic mass is 12. Next, hydrogen, it's given percentage is 13.33, divide by hydrogen atomic mass is 1. Then nitrogen, so what is the percentage? 46.67 percentage, divide by its atomic mass is 14. That's it. Immediately the problem gets solved now. How? Just observe. 40 by 12 is 3.33, right? Is to 13.33. What about the next one? 46 divided by 14. 14 3 is 42. So again it will be 3.33. 3.33. Now how to find out the simplest whole number? Divide by 3.33, isn't it? So it is 1. When you divide 13 by 3.33, 3 4s, isn't it? So you'll get it as 4 is to 1 again. So what is the ratio, you tell me? C1, H4 and N. So which is that option? Option C. This is how you have to do in competitive examination. Okay. Now next, 7th one. What amount of dioxin contains a 1.8 into 10 to the power 22 molecules 2015. So you can observe here, after 2018, I mean before 2018, I'm sorry, before 2018, the questions were based on mole and empirical formula or molecular formula. Next in 2014 and below that year, you will be having question, or you are going to see the questions from these concepts. So let us complete this problem. What amount of dioxygen? So what amount is asked? So mass. and molecule to be connected. So what is that common factor which connect these two? Moles. So convert that into moles. Okay, so what you do there, amount of dioxin. Let us understand this problem in this way. 1 mole of oxygen contains Avogadro number of molecules. Do you agree? That is 6.02 into 10 to the power 23 molecules. So 1 mole of dioxin also is equal to its molar mass, which is 32 gram. So you relate that mass and molecules. How? Let me go for the solution of this question. So we know that what we know here, 32 gram of oxygen, 32 gram of oxygen, am I right, which is nothing but 1 mole, so is equivalent to or contains how many? 6.02 into 10 to the power 23 molecules. Am I right? Yes. Our problem is solved. It's a cross multiplication, isn't it? So 1.8 into 10 to the power how many? 22 molecules contains what amount of oxygen? Done. So 1.8 into 32, of course 10 to the power 22 divided by 6. So when you simplify it, you'll get the answer for this. How to simplify? That part you know, I guess. 1.8 into 32 you do. I mean 10 to the 10 raised to 22, let it be. Then divide by 6. So 6 ones are 6.3s are 0.3 into 32. How much it is? 9.6. But you have 10 to the power in the denominator as 1. So 9.6 divided by 10 is 0.96. So option B will be your answer in this case. So that is about the 7th problem and in the year 2015. Now let us move on to the next 2014, that is 8th problem. 8th question is to calculate the molecular formula of the compound. So we are given with few data here, dear students. The total mass of the organic compound which is taken, then if you go for combustion reaction of 0.30 gram of organic compound, you will be getting 0.44 gram of carbon dioxide and then 0.18 gram of water. So obviously the remaining percentage is supposed to be the oxygen, isn't it? Once you find out the percentage of carbon with this data and hydrogen from 0.18 gram of water, is it not possible to calculate oxygen percentage? Yes, because 100 minus the sum of these two percentages will give you the oxygen percentage. So once you know percentage of the elements present in the organic compound, yes, mole ratio can be found out by dividing that percentage with the mass of or atomic mass of the respective elements. So once you find out the mole ratio, empirical formula can be computed. I'm just explaining you what we supposed to do or what we require to do to compute this problem. So once we get the percentage and mole ratio, empirical formula can be written, then from which molecular formula can be deduced. What is the relation between empirical formula and molecular formula? Molecular formula is equal to n, an integer, into empirical formula. What is that n? We can calculate that with the help of molar mass. So once we know molar mass, empirical formula mass can be obtained from the empirical formula, and n factor, then the final compound, molecular formula of the compound can be deduced. So shall we go for this? Yes. So calculation of percentage of carbon from carbon dioxide in water, we dealt even in organic chemistry basic principles and techniques. Do you remember the qualitative analysis and quantitative analysis we have done? So quantitatively carbon and hydrogen percentage can be obtained by Liebig's method. So it is just the application of Liebig's method. So what I'll do is I'll go directly, okay. Percentage of carbon is equal to, I have 0.44 gram of carbon dioxide out of 0.3 gram of the organic compound. Is that fine? Yes. Now standard formula is that carbon dioxide contains 12 gram of carbon and 44 gram of carbon dioxide in it. So every 44 gram of carbon dioxide has got 12 gram of carbon. So I'll make use of that data. So 12 divided by 44 and percentage in 100, isn't it? So you simplify this once and you 100 times 100 get cancels. So 12 by 0.3 is nothing but 40. So I am having 40% of carbon. So what is the mole ratio? Mole ratio, am I right, is equal to, tell me, 40 divided by 12 carbon, no? So this is nothing but 3.33. So I got to know now what is the mole ratio of carbon. What about percentage of hydrogen, thereby mole ratio of it? Percentage of hydrogen is equal to, I have 0.18 gram, so let me write it 0.18, and I have 0.30 gram of the organic compound into, so every 2 gram of hydrogen in water. Okay, so total it will be 18 gram of water. So mass of hydrogen divided by total mass of the compound, which is water, into 100 will be its percentage. So again here ones are 100 times, isn't it? So cancels 20 by 3, which is nothing but 6.66, isn't it? So here you will get it as 6.66. So what is the mole ratio? It itself is a mole ratio because divided by 1 it is atomic mass of hydrogen. So 6.66 percentage. So mole ratio equal to same. Mole ratio is equal to 6.66 itself. Now remaining is obviously oxygen, right? So 100, let me do minus, it is 40 percentage plus 6.66 percentage, which will give you 53 point, isn't it? This is 46.66, so 53.34. Am I right? So what is the mole ratio now for oxygen? Mole ratio is equal to, tell me, it is 53.34 divided by oxygen atomic mass is 16, so again it will come as 3.33 itself. Okay, so 3.33. So obviously I came to know what is the empirical formula now. Simple whole number ratio is 1, right? Here 3.33 by 3.331, here it is 2, and here again 1. So empirical formula, I'll write here, empirical formula is equal to, tell me, C1 H2 and O1. Is that fine? So what is our N factor? N equal to molecular formula mass 60 by empirical formula mass 16 plus 2, 18, and 12, which is 30, right? So N factor is 2. What is the molecular formula then? So molecular formula is equal to N into empirical formula C2H4O2. So which is that option, dear students? Yes, option D is the right choice here. So in a simple way you can do in this way. Okay, let me come to the next one, 9th. In the year 2013, this question is asked, 2013, the mass of 112 cm cube of ammonia at STP is. Very simple question. Question is very simple, and concept also, let me tell you, very simple. Okay, so what is the connection here, or which relation to be established now? Mass and volume, right? So we have to connect mass of ammonia to its volume. Through what parameter it is connected? Mole, right? So we know that 1 mole of ammonia equal to 17 gram because it's molar mass, and at the same time 1 mole of ammonia gas occupy 22,400 cm cube, right? So we will use that connection now, or the relation. So I'll write 17 gram is equivalent to, of ammonia I'm writing, 17 gram of ammonia is equivalent to 22,400 cm cube. Very simple, direct one. Now question is 112 cm cube of ammonia, or to occupy 112 cm cube of ammonia, how many grams to be taken? Cross multiply, right? So this is 112 ones are, and this is 2 times, so totally 200 times, which is nothing but 17 by 200, 17 by 200, which is nothing but 0.085 gram. So option A is your right choice. So in a very simple single step you can complete this if you are very good in the concept. Of course, for that the synopsis part has to be very clear on these. Next, coming to the 10th question, which is again in the year 2013, so you can make a note of this. 2013 you had 2 questions on the same chapter, right? Some basic concepts of chemistry. Okay, so moving ahead, again it is related to empirical formula. Half of this problem is asked here if you observe carefully, isn't it, dear students? See here, after calculating empirical formula you computed molecule formula. Here empirical formula they have given, only molecule formula is asked. So quite simple. The last step, n factor, you have to find it. So shall we go for that? Yes, right? Okay. So what is that? Molecular mass is 90. Empirical formula is given. So you find the empirical formula mass by adding atomic masses of those elements. So I'll write here n is equal to molecular formula mass divided by, or molecular mass, okay, molecular mass divided by empirical formula mass. So what is that? Molecular mass is 90 divided by empirical formula mass is 12 plus 2 14 plus 16 30, isn't it? So 30, what is the answer? 3. So multiply the empirical formula by 3. C3H6O3. Is there? Yes, option A. So that is your answer for this question. Done. Hope this chapter concepts are very easy, and if you make a note of the already solved problem concepts, right, so we can clearly say that one mole concept, then empirical formula and molecular formula concept, and the most recently asked questions on the stoichiometry calculation, limiting reagent. Done. So let us move on to the next problem. Okay, 2013 we come across now. Let us move on to the next one. So 11th one. Moving on to the next question, dear students, 11th one, and it is in the year of 2013 again. Okay, the number of water molecules present in a drop of water, very interesting, weighing 0.018 gram is. So you have to find out if a water drop weighs 0.018 gram, how many water molecules are going to be present. Connected here, molecules and mass. So these two are connected through mole. So 1 mole of any substance, you know, is equal to, or is having, or is containing Avogadro number of molecules. So you know that molar mass of water is 18 gram, right? So 18 gram of water will contain 6.02 into 10 raised to 23 molecules. Now our weight of the water drop is this 0.018 gram. How many molecules will be there? Simple one step calculation. If you do, then you write how to do this. Moles, 1 mole of what? 18 gram contains 18 gram is equivalent to 6.02 into 10 to the power 23 molecules, isn't it? So now the question is 0.018 gram is equal to, or will contain how many molecules? I'll write this as 18 into 10 raised to minus 3. So 10 to the power 23 and minus will become 10 to the power 20. 6.02 into 10 to the power 20 divided by 18, and 18 get cancelled. So your answer is 6.02 into 10 to the power 20. Which is that option? Yes, D. Done. Within a minute you can complete this. Fine. Moving on to the next 12th one again. This is in 2012, the year. So volume of 0.1 molar oxalic acid that can be completely oxidized by 20 ml of the given strength 0.025 molar KMnO4. So it's a titration which is between potassium permanganate and oxalic acid. Now volume is asked, strength of acid is given, or the one of the reagent is given, oxidizing and reducing agent. So redox reaction, KMnO4 is oxidizing agent and oxalic acid has to behave there as reducing agent. So now if you observe, volume and strength of KMnO4 is given, and you need to find out volume of oxalic acid, and they have provided concentration of oxalic acid. Now V1M1 is equal to V2M2 formula can be applied, okay, but here the moles, number of moles of oxidizing reducing agents are different. So once you know the reaction between them, equation, immediately you can write this. So always oxalic acid and KMnO4 when reacts, the stoichiometric coefficient will be 2 and 5. So this will come to know by writing the equation. So shall we write that equation? So what is that? Oxalic acid H2C2O4 reacts with KMnO4, potassium permanganate. Okay. So in acidic medium reaction takes place. So H2SO4, you can write the product now. Oxalic acid is a reducing agent, so it will get oxidized to carbon dioxide. Fine, no? KMnO4 is oxidizing agent, so it will give K2SO4 and MnSO4. I'll write down, okay, MnSO4 and the other product being water, H2O. So this is a complete equation for you, dear students. Okay, now what you're supposed to do here, you balance the equation. So balance the equation. So KMnO4, let me, K2 is there, so I'll multiply by 2 KMnO4. Now in order to balance carbon there, okay, so I'll go for 5 moles of H2, C2O4, so that I have to multiply by 5 CO2 there, isn't it? Here C2, 5 into 2, 10, therefore I'll multiply by 10 here. Then what else? Manganese 2, so 2 MnSO4, remaining is water. How many oxygen, hydrogen atoms here? Let me multiply by 8 H2O. So now only H2SO4 to be balanced, to balance hydrogen atom, here 10, here 16, so let me multiply by 3. So 6 plus 10, 16. So this is a balanced equation, supposed to be known. Okay, so I'm not explaining here how to balance this equation anyway, but if you remember some of the redox reactions, of course you have to, okay, to make it, I mean to compute this problem in a faster rate, you're supposed to remember the equation or at least the ratio. So it is 5 moles of oxalic acid and 2 moles of KMnO4. That's what we require here. If we know that directly, we can apply the formula. What is that? V1M1 by N1, okay, for oxalic acid H2SO4, I'm sorry, H2C2O4 should be equal to V2M2 by N2, and this is for what? KMnO4. So done, your problem is completed, dear student. Why? V1 to be found out, and M1 is 0.1, N1 is oxalic acid 5, right? So here it is 0.1 by 5, and here V2 20 ml, and that of M2 is 0.025, N2 is 2 KMnO4. So if you calculate it immediately, your answer will be ready. So hope you will do it. V1, substitute for V1, let it be V1 itself, because that's what we found out. We have to find out. So M1 you write it as 0.1. So I'll do it here. Okay. So it is V1 into 0.1 divided by that of N1 is 5 equal to V2 is 20 and 0.025 divided by 2. Simplify this. Okay, 2 ones are 2 tens are, so this will become 0.25 into 5, 0.25 into 5, so divide by 0.1, so it will be 12 point, how much it is? 12.5, isn't it? So option C will be your answer. Simple that. Next one, 2012, in the year 2012 3 questions were asked, so I'm computing the next 13th one. The total number of electrons in 18 ml of water. So 1 mole of water contains how many electrons? Avogadro number of electrons, right? 1 mole. Now here 1 mole of water to found out, to calculate it, you should know 1 molecule of water, how many electrons are present. So in 1 molecule, 2 electrons from hydrogen and 8 electrons from oxygen. So totally there will be 10 electrons in 1 molecule of water. So 1 mole of water will contain 10 into Avogadro number of electrons. That's all. Because 18 ml is nothing but 1 mole of water. So 18 ml of H2O is equal to, tell me, 10, am I right? 1 mole of water. So let me write 1 mole of water. So I can equate that. How? This is nothing but 10 into 6.02 into 10 to the power 23 electrons. Do you agree? Why this 10? Because 1 molecule of water will contain 2 plus 10, right? 2 plus 8. Why I am doing that? Okay, so 2 plus 8, totally 10. Oxygen 8 electron, 2 hydrogen, so totally 10 electrons. So 10 into 6.02 into 10 to the power 23. So totally 6.02 into 10 to the power 24. So your option C is the right answer for that. Simple. Next, last one, 14th one, last in the sense 2012. Okay. Now 100 ml of 0.1 molar acetic acid, read carefully, neutralized using standard sodium hydroxide solution. So typical acid base reaction. completely if it is neutralized, acetic acid plus sodium hydroxide will give sodium acetate. After the complete electrolysis, so you have to calculate the volume of ethane obtained when you electrolyze obtained salt. Okay, electrolysis of sodium salt of carboxylic acid, we know the name reaction it is, isn't it? Coal-based electrolytic method. So to prepare alkane, so ethane to be found out now. What volume of ethane is going to liberate? So let us write that coal-based electrolysis reaction. What is that? Sodium acetate, CH3COONA, isn't it? To be electrolyzed. So let us electrolysis, carry out electrolysis process. Electrolysis, yes, in aqueous medium, of course, right? So aqueous medium, water will be there anyway. So obtained, they told ethane, so I'll write H2O here. Okay, aqueous medium I have written, but still not to balance the equation, you need to write water, H2O there in the medium. So CH3 CH3, ethane is going to be produced. What are the byproducts? Carbon dioxide, then hydrogen, isn't it? So sodium hydroxide. After that you will be having sodium hydroxide. So this is your coal-based electrolytic method reaction, isn't it? Now what you're supposed to do here? So you see, now while balancing you'll get 2, or you have to write 2 moles of the salt to get 1 mole of the alkane, which is ethane suggested there. So how can you complete this then? So once you find out how many moles of sodium acetate is formed, you can connect to the ethane, isn't it? Volume can be related later, molar volume concept. So find out how many moles of sodium acetate is going to produced. Sodium acetate is formed depending on the acetic acid taken, because it's being completely neutralized. So 100 ml of 0.1 molar acetic acid is equal to how many moles? 100 ml of 0.1 molar. You have a formula. What is that? Molarity equal to number of moles by volume in liter. So can't you find out number of moles? How? Molarity and volume you multiply. So I'll write here M is equal to N by V. So this is one formula to remember there. So molarity is given 0.1. Volume is 100. 100 into 0.1 is 10. So it is ml, milliliter. Therefore obtained that number of moles will be in milli. So you have millimoles, 10 millimoles of this salt. So what do you mean by 10 millimole? 10 millimole, which is equal to 0.01 mole. Am I right? I have 0.01 millimole of, 0.01 mole or 10 millimole of salt. Now can't I find out what is a mole of ethane produced there? Yes, half of it. So obtained, right, ethane is 0.005 mole. 0.01, half of it 0.005. Now it's fine. 1 mole of ethane equal to 22.4 liter. So 0.005 mole equal to how much? Right? So that is, now okay, we can relate this. How? 1 mole of C2H6 is equivalent to, or it will occupy 22,400 ml. Therefore I have here 0.005 mole. How much? So 0.005 into 22,400. So 5 into 10 to the minus 3, right? There will be you will be getting 22.4 into 5, right? So your answer will be in this case how much? 112, isn't it? 22 into 0.5. So you'll get as 112 ml of ethane gas, which is coming out in this particular case. So therefore the option A is a right choice for this particular question. Is that okay? Shall we move ahead? So next one, 15th one. 15th question, dear students, here equivalent mass of a certain bivalent metal is 20. So equivalent weight is given. The valency is 2, bivalent. The molecular mass of the anhydrous chloride obtained from that is asked. So in the year 2012. Okay. So once you write the formula, okay, you can calculate molecular mass. But you should know what is the atomic mass of the individual atoms involved in the molecule, isn't it? So what we do is we write a molecular formula first. So metal being bivalent, M2 plus, right? And chloride, you know, its charge is -1. So cross the valency, therefore formula is M, right, Cl2. So this is the formula of the compound. Now metal atomic mass to be known. Chlorine, you know what is the atomic mass and thereby the molecular mass, isn't it? So molecular mass is 71. So once you compute what is the metal atomic mass, the problem is solved. So we'll do that with the formula. What is the formula? You know that, or you're supposed to know that. What is that? Atomic mass equal to atomic mass supposed to be equal to equivalent mass into valency. So this is a basic formula, isn't it? So equivalent mass is 20, valence is 2, that is equal to 40. So atomic mass of metal is 40 and that of your halogen chlorine is 71, so that is 111 gram. So option B is your right answer in this case. Okay, next 16th one, 2011 question. It is 25 gram of each of the following gases, point to be noted down. So 20 mass is constant, 25 gram of HCl, HBr, HI and HF are taken at 27 degrees Celsius and 600 mm of pressure. So pressure and temperature constant, same amount of different gases are taken. This is a valid point. Now which of these will have least volume? Now which law to be applied? Can you guess which law to be applied here? Avogadro's law, isn't it? Because volume and the mass or pressure to be related, so you supposed to know that volume of a gas is directly proportional to number of moles, and thereby the volume and number of moles, isn't it? Has to be related. These two parameters has to be related. So we have volume and number of moles, and we know that number of moles is equal to mass divided by molar mass. So there is only one way is there to find out the gas which is having least volume. So mass is constant, 25 gram each of them. Molar mass will differ because halogens are different. So one which is having highest molar mass will have least number of mole, thereby volume is least, because volume is directly related to number of moles. Number of moles inversely related to molar mass. Which of these has got the least volume? The one which is having highest molar mass, that is hydrogen iodide, and therefore this will have a least volume. Done? Simple. Okay, next 17th one here. Again it is in 2011. The question is asked, excess of AgNO3 is added to 100 ml of 0.1 molar complexities. So this question can be asked even, or we can take this question in coordination compound as well. Why? Penta, aqua, chloro, chromium complexities. So coordination compound, isn't it? So we have 100 ml of 0.01 molar this complex solution, and to this we are adding AgNO3 in excess. The question is, what mass of AgCl is getting precipitated? Once you know the structure of the complex, so in coordination compound you're supposed to know that whatever the ions present outside the coordination sphere can be precipitated, they can be ionized. Okay, so whatever ions present within the coordination sphere, you cannot ionize it, so thereby it won't get precipitated. Only the ions present outside the coordination sphere. So definitely you have to write the formula, then only you'll come to know. Write the formula of this complex. What is the formula? Formula is chromium being central metal atom there. Okay, and next penta aqua, so H2O 5 times chlorine, and chloride it is. So this is a complex given to us. Now when you add excess of AgNO3, whatever the amount of excess AgNO3 add, only precipitation of AgCl, right? Or AgCl will get precipitated only to the extent of 2 chloride ions. Did you get that? So once you find out chloride ion concentration, AgCl can be obtained. So how to find it out? Therefore we have chloride molar concentration equal to, molar concentration formula you know, right? Number of moles by volume in liter. So concentration chloride, you write number of moles how many? 100 ml of 0.01 molar. So let me multiply that 100 into 0.01, isn't it? But each molecule will have 2 chloride ions, so multiply by 2 is required because 2 chloride ions will be there, divided by, it is in liter, no molarity, therefore you have to divide by 1000, 1 liter. So to make it into the liters, now you simplify this. What is the answer here? 100 into 0.01 is 1, which is nothing but 2 numerator, denominator 1000, so which is nothing but 0.002 molar. So concentration of chloride is obtained. Next part is very simple. What are you supposed to do? Multiply by molar mass of AgCl. Therefore, mass of AgCl, right? Mass of AgCl is equal to 0.002 into silver chloride 143.5 gram. So this is nothing but 2. I'll write this as 2 into 10 to the power 3 minus 3 supposed to be. So 2 into 10 raised to minus 3. 2 into 143.5 is 287. So 287 into 10 raised to minus 3 is there, right? Gram. So this is your silver chloride which is going to get precipitated. So what is the option? Option B is a right choice in this case. So these are the last 10 years questions from some basic concepts of chemistry. So you can see now exactly what are the concepts which are important, isn't it? Limiting reactant 3-4 times asked, then the stoichiometry calculation again equal number of times, then the empirical and molecular formula, then finally moles. Only these 5 concepts were being asked in the last 10 years of your CET examination. And even this is true, or this is important for the other national level exams as well. Okay, so concentrate much more on these concepts, dear student, so that, as I said earlier, you can excel. Okay, so I'll be back with one more chapter in the next video. That's it for today. Thank you all.